4.5 day 1, solving quadratics using square roots. So, if you remember when we talk about like the square root of 7, this is called a radical. This radical is a square root, also known as a square root. And in the 7 inside, that's called the radicand. Perfect squares, we're going to list our perfect squares here. So I got 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. That's about as good as you can get. So we got 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, etc. all the way up to 12 squared. Simplifying these things. So to simplify a radical, you want to split it up into one of these perfect squares in a number. So 20 is divisible by 4. So it's 4 times 5. So it's really kind of like the square root of 4 times the square root of 5. And the square root of 4 gives me 2. Square root of 5 I can't do anything with. So my answer would be 2 square root of 5. Just trying to simplify it. 27, what perfect square goes into 27? Looks like 9 would. So it's like the square root of 9 times the square root of 3. Square root of 9 becomes 3. So I can simplify it to 3 square root of 3. Square root of 48. Ooh, what goes in here? Square root of 48. 4 does. So let's do 4. Square root of 4 times 48 divided by 4, which is 12. This becomes 2. 12. Can we split 12 down even further? Yeah, because square root of 4 is in there again. So now I have 2 times 2 square root 3, which becomes 4 square root 3. One more, 32. Oh, we can definitely take a 4 out of there. So square root of 4 and 8, and that becomes 2. And 8, ooh, we got square root of 4 and square root of 2 again. So that becomes 2. So I got like 2 times 2 square root of 2, which becomes 4 square root of 2. Let's keep going. Basic multiplication, so yeah, kind of like what we did before, but backwards. We got square root of 2 times square root of 6 gives me square root of 12. And now you can simplify that. Be square root of 4, square root of 3. So I got 2 square root 3. Here we go, I'm going to multiply the numbers first. So I got negative 6. Square root 5 times 3 gives me 15. Can we take any perfect squares out of that? No. So you just leave it. 6 would stay on the outside. Square root of 15 times square root of 5 becomes square root of 75. Okay, we've got any perfect squares that can come out of that. Looks like 25 could. So square root of 25 and square root of 3. So this becomes 6 times 5 square root of 3. So I got 30 square root of 3. Now, just like you can do with anything else, you can simplify these in too. Advanced multiplication. 3 root 2 times root 6 becomes 3 root 12. 3 root 2 times negative 5 gives me negative 15 root 2. So that when I simplify this, it becomes square root of 4 and square root of 3. So it's like I got 3 times 2 square root of 3 minus 15 square root of 2. So I get 6 root 3 minus 15 root 2. And just like that before, too, we can FOIL. So we got first gives me 14 outside minus 21 square root 2 inside plus 2 square root 8 and last minus 3 square root 16. 8 is going to be simplified down, 4 and 2. 16 just straight becomes 4. So now we got 14 minus 21 square root 2 plus 2 times 2 square root 2 minus 3 times 4. So we got a couple things here. We got these that we can combine. 14 minus 12 gives me 2. Negative 21 root 2 plus 4 root 2 gives me negative 17 root 2. Then the last thing here we want to do to rationalize these things, which we'll get into a little bit more, but basic division here. This is like the same as square root of 2 over 8. And 2 over 8 you can simplify down to 1 over 4, which you can also look at and say, well, 1 is a perfect square and 4 is a perfect square. So it's kind of like square root of 1 over square root of 4, and square root of 1 is 1, square root of 4 is 2. Same thing for this one, becomes square root of 12 over square root of 49. Square root of 49 is nice and easy, it turns to 7. 12 becomes square root of 4 and square root of 3. So we got 2 root 3 over 7.